Hello guys and welcome back to the Maths and Physics blog. Today we're going to answer this question here. Find all unit vectors in R3 which are orthogonal to both -1, -3, 2, which is the vector transposed, and 0, 1, 1, which is the other vector transposed. So we're going to do this. It means that the orthogonality means that the scalar product is 0, and so it's equivalent to the following equations if we just set them both equal to 0, taking them and putting them components in. And then we also have 0x plus 1y plus 1z, which, I mean, this one can be written a bit nicer, so it's like this. So we need to find a system equation so which these all kind of look a bit nicer, and as we can see we have an equation here, so we can just set z equal to -y, and then we can sub that into this first one here. So if we take this down here, we take this over here, we see that x minus x minus 3y, z equals -y minus 2y equals 0. We can get a value for x in terms of y, so we get -5y equals 0, and so we get x equals -5y. So this means that the solution to the set of these two equations is the set -5y given by x here, y is just equal to y, and then we have z equals -y here, which is the vector solution for all y in the real numbers. So this is a set of vectors which is orthogonal to both of these given vectors here. But the question is asking for us to find all the unit vectors. So we need to find the norm, or the norm of this equation here, this set of equation here, in order to then find a value for y in which the sum is equal to 1. So this is the first part done. So now we need to find, the way we find the norm is the length. So if you watch back to one of our bilinear form videos, we'll see that the way to do this is the equation here. So let's just set, I don't know, let's just call it that. That is equal to the square root of the scalar product of them two. So the way we can do this is just the square root of -5y, y minus y, times by -5y, y minus y, which is equivalent to the square root of -5y times -5y, which is 25y squared, plus y times y, which is y squared, plus -y times -y, which is y squared, which nicely, well, not really nicely, but it gets down to 27y squared. So we need to then find a number so that this is equal to 1, and then that will give us our unit vectors. So the only number that makes this equal to 1 is that when y squared equals 1 over 27, because then that cancels out this 27, and then the square root of 1 is just 1. So that means that y is equal to the plus or minus of 1 over the square root of 27, because we've just squared it, and obviously you've got to have the plus or minus because it can be positive or negative. So then this is our final bit. We just put this in for our y's, and then we find the unit vectors of for they are orthogonal to both the vectors up here. So then we get the two solutions. So the two unit vectors which are orthogonal to both vectors are, we have -5 over, let's move up a little bit, root 27, we have 1 over root 27, and we have -1 over root 27. So we've just put our y that we got, we've started off with the positive one, we just put it in the value we found up here, and then we got the other one being 5 over root 27 minus 1 over root 27 and 1 over root 27. So these are both these are the two unit vectors you get which are orthogonal to both these vectors. I hope that guys makes sense. Thank you guys for watching. Make sure you like, subscribe, comment any videos you'd like to see, and I'll see you guys in the next video. Goodbye.